Student, in this particular class, we will study about the one of the major important component in Java language, that is JVM, right? So, starting with this JVM part, the first thing that we require that what is JVM? So, that is a Java virtual machine. So, in this particular class, we will discuss that what basic architecture of JVM is and how this Java, JVM help us to just process a particular program to give the specified output. Okay, so we will start like this, that how, first of all, we will understand that how basically Java works, right? So previously we had discussed some of the features of the Java that extensively make it a very rich language. There were some features were there. So okay, the first of all we will discuss that how Java will work. Okay, so as you know that any in a while typing or while giving instructions in any language, first of all what we require, that is a source code over there. Okay, so the first thing that we require in any type of a language, from where we started doing the programming part and each and everything, that is the source code. Now here what will happen, our Java compiler will convert this particular source code to the bytecode. So it will convert it to the bytecode like this. This bytecode will be, so our Java compiler will convert our source code to the bytecode. Now this particular bytecode is under some particular format, that is a hexadecimal format is here. Okay. So if you remember that what is the purpose of this bytecode poses a very good feature in Java that makes it more secure, that makes it portable, and it also makes it a platform independent, right? So this is a source code, and with the help of this Java compiler, we have converted the source code to the bytecode. And this particular bytecode is available in which format? That is the hexadecimal format. Now what happened? This particular bytecode then moves to this JVM part. This particular bytecode when it moves to the JVM part. Now, what is the purpose of this JVM part? That it will comprises of two things. One is the JIT compiler. JIT compiler. That is the just-in-time compiler. Fine. Next is the Java interpreter is there. We have this proper Java interpreter is there. Fine. Next is the Java interpreter, and all this thing, that is JIT and the Java interpreter, that will be converted to the runtime system. So we have a proper runtime system over there. Fine. So there will be a runtime system over here. So that will convert the source code to the, that will convert this particular bytecode to the required output. Okay, so I just draw it again and I'll just write like this. So what we are having, this is the bytecode available, and what we will do, this particular bytecode will be moved to this JVM part. That JVM part again will be consisting of two things. One is the just-in-time compiler and the another part is the Java interpreter. So interpreter, what is the work of this interpreter? That will check your instruction codes line by line, one by one, to see if there is any type of an error. So basically, this just-in-time compiler, why we require this just-in-time compiler? To just speed up the execution of the program. To speed up the execution, to speed up the compilation part of the program. So this is the main purpose of this just-in-time compiler. So it is just speed up the execution part of the program. Both is just in time and Java interpreter. What it will do, it is a part of your runtime system. Okay, so it is a part of your runtime system. So we are having this runtime system. Clear? So this is your just in time and the Java interpreter. So JVM basically consists of these three things: just in time, Java interpreter, and the runtime system that we are having. And after that, so what is the purpose of this Java interpreter? Just in time compiler will speed up the execution. What this Java interpreter will do? It will just converts the bytecode into the machine code. It converts the bytecode into the machine code. Fine. So this is the main area, that is the JVM part, that will help us to execute. It will just help us to how it will convert the required source code, and it will give us the required output. But for this particular JVM part, what is required? What type of input it required? That is in the form of a bytecode. Okay, so bytecode is required, not exactly the source code that we require, but it is a bytecode that will be taken as an input to this JVM part. And finally, after doing all those processing part, we can get the output of the code. So finally, what we will be doing, we will be getting the output of this program. So finally, it will print out the output of the program. Okay, so this is regardingly a main brief overview that we have given, that how basically a Java works. Okay, so previously we have discussed its features part, but now we are discussing that when we implement some particular program in this Java language, so how it will help us. So it will how that particular program is being executed in the case of a Java language. So we are having the source code. Source code is being converted to the bytecode with the help of a Java compiler. After this bytecode will be given to this JVM part, and this JVM part will be having two things over here. That is just in time compiler is there, Java interpreter is there, and the runtime system that we are having. Okay, so it will, what Java interpreter will do, it will just convert the bytecode into the machine code. And just in time compiler, what it will do, it will just speed up the execution part in Java. Clear? And after that, finally, when it will do all those processing in the runtime system, we can finally get the output of that particular code. Okay, so this is basically the brief overview that how Java works. But now we will discuss that how what basic structure this JVM has. Okay, so we will start with this particular part, that what is the basic structure of this JVM. So I just once again I will just draw a diagram. So this is a structure of this JVM that we will be discussing over here. Okay, so first of all, we are having a class loader here, like this. This is a class loader. In this particular class loader, it will represent then we have the memory area. This is your memory area. Okay, so we are having this. We have divided this memory area into different parts. So first of all is the method area. Second is the heap area. Third one is the stack area. Fourth one is PC register. And the last one is the native method area. Native method area. Fine. So I just again repeated. Method area is here, heap area is here, stack area, PC register, and the native method area. So these are the basic, we can say that memory areas available when we talk about this JVM. So this is the basically structure of JVM. Fine. Next, after this, what we are having, we are from this particular part, we have to go to the execution engine. What we are having over here, that is the execution engine. Execution engine is there. Fine. Now this particular execution engine, after this particular part, it will move to this Java native. It is Java native interface. Java native interface will be there. Okay. We usually refer to it as JNI. JNI. That is Java native interface is there, and how we are representing is as a JNI. Finally, we also have to include different native method libraries. Native method libraries. That is native method libraries. Is it fine? So this is a basic structure that we are having, and here you can see that how we are connecting with each other. So the first basic component in this Java virtual machine is that we are having this class loader. Further, we have this memory area. From this memory area, we can go to this execution engine part, and this execution engine part will go work with this Java native interface. Okay, so with the help of this interface, we can connect with the different native method libraries. Okay, so we will discuss each and everything one by one. But before that, you must understand that this is a basic structure of Java, the JVM that we follow. Okay, so before JVM, there is only one thing, that what we are doing, that we are converting the source code into the that is a bytecode with the help of a Java compiler. Fine. After that, this particular bytecode will move to this JVM part, and under this JVM part, different execution levels will be there. So different steps it will follow, and finally it will give you the output. Clear? So we will move towards the PPT portion. In that, we will discuss each and everything very clearly. So we can start with the first part, that what basically a virtual machine is. So how we can define a virtual machine? That is we can define like a virtual machine that is not physically present. Okay. So anything that is not a physically present, we can define under the category of the virtual machine. So we now switching to this PPT portion. So I'm going to share my screen with you. So So we can go through over here that this was that how basically a Java works and what basic components that we use in order to execute a particular Java program. Fine. Now the next thing that we require here is the that we will start with the this virtual machine. So what basically a virtual machine is, that is a software simulation of a machine which can perform operation as to the physical machine. So basically it is not physically present. That's why we use a word virtual. Okay, so it is usually known as a guest which is created within the another environment. So that another environment is referred as a host. So what we can do, that a single host, within a single host we can have so many different virtual machine. But in case of a Java, when we are using a virtual machine, we usually represent it as a Java virtual machine. Okay, so like this is one of the example, like we have a computer calculator software in operating system which is not physically present, but it performs all the functions similar to the physical calculator. So similarly, that's why we use we usually say that whatever the Java language is a portable language, because we just transfer this particular bytecode to the different machines, and that on that particular different machine the output or the whatever the execution that happens, that will happen under that particular environment of the Java part. Okay, so that execution will be happening under this Java environment. That's why it is known as a Java virtual machine. That's why it is a portable, because it works under its own environment. So basically, we have two types of a virtual machine. One is the hardware based or a system based virtual machine is there. Second one is the application based or the process based virtual machine. So we usually refer that JVM is a application based virtual machine or a process based virtual machine. Fine. So because that is, as it is not dependent on any particular hardware, so this is application based or a process based virtual machine. Now the next thing is that as you know that this is the main diagram of this Java virtual machine. So you can see over here that in Java virtual machine, it is basically the runtime engine that is responsible to run the Java based application. Okay, so that is the runtime engine that we, if you remember the first diagram, so that is the runtime engine that is responsible for running the Java based application. Now what are the its main tasks? That it has to load the class file, and secondly it will execute that class file. Okay, so basic architecture consists of these three major things, that is a class loader, memory areas are there, execution engine is there, we have a Java native interfaces. This basically interface provide interface between the native method libraries and the execution engine, right? So this is how so this is the execution engine. Then we have Java native interfaces is there and native method library. Now, the next system is that class loader subsystem. Okay, so the very first component of Java virtual machine is the class loader subsystem. Okay, so what basically a class loader subsystem do? It consists of these three tasks. Okay, so a class loader will be consisting of these three tasks. One is the loading, second one is the linking, and the third one is the initialization. Fine. So we are discussing the very first part of this JVM, and that particular first part is the class loader. But before we need to discuss this particular class loader, which consists of further three tasks. One is loading, linking, and the initialization. If we go for the first part, that is a loading part. That means in a class loader, the first thing that will happen, that it will load. Now the bytecode that is given as the input to the JVM, it is in the form of a class form. Okay, so its extension will be always as dot class. Fine. So it consists of these three things: bootstrap class loader, extension class loader, and the application class loader. These are the three different loaders that is available to us. Secondly, we have to link this particular loading bar to the final part portion over here. So we need to first verify that whatever the input is given, we have to prepare for that, and if there is any type of error, we need to resolve that particular thing. And after preparing it for the execution part, we need to have this initialization phase. Now, what will happen in this initialization phase? Like we may be using some static variables. Okay, so we are required that all static variables are assigned within the original values. If we are having some particular static blocks that should be executed from top to bottom. So these are some initialization that will occur in my program. So we can again study this particular thing one by one. So the very first thing is the loading portion. So you just keep this diagram in your mind: loading, linking, and the initialization. So the very first thing is the loading part. So in loading part, what will happen? It will read the dot class file and store the corresponding information in the method area. Okay, so we are also having that method area that we will discuss in the memory area part, but still you can just remember that it will load whatever the dot class file that will be available to us. Okay, so for each class file, JVM will store the following information. So while loading all those things, JVM will store the following things in the method area. That is fully qualified class name, its parent's class name, methods information, variables, constructors, modifiers, and constant. So all these things are being stored in class loader subsystem during the time of loading. Now, again, there are three types of a class loader. Bootstrap loader is there. So that is responsible to load the class present in RT dot jr, and second one is the extension class loader. That is if we are having we need to load the classes from the extension classes. So this is the basic you can see that we have this jdk, jre, and the library portion. So all these type of a file are loaded in the boot class. Similarly, we have an extension class loader. So in which again we need to load the classes from the extension class. And the last one is the application class loader, that is required to load the classes from the application class file. Okay, so it internally uses the environmental variable class path. Okay, so whatever the environmental variables that we will be defining, we will be using in this application class loader. So we will not go in so much detail, but meanwhile you just understand that first thing that you require, that is to load the required class file. And while recording all those class file, we are required to say JVM will store each and every this following type of a data on it. Okay, and everything will be stored in the method area. Next is the linking part. Now linking part is what? Again, in this particular linking portion, if you see this diagram, we have three things: verify, prepare, and resolve. So what will happen in the verification part, that in this particular bytecode verify will be there, that will check whether the class file is generated by a valid compiler or not. So this is also one of the features that make Java a more secure language. Okay, so if something gets verification gets failed, so such type of error will be there. Okay, this is because of this particular part. Again, I'm saying that if you remember last video lecture or a lecture, we have discussed that we have a bytecode verifier. So this bytecode verifier will work like this. Second thing is that is the preparation part. So in this particular part, JVM will allocate memory for the class level static variables. So again, in the preparation part, we will be allocating the required memory for the class. Okay, for that particular class level static variables. And resolution is there, that if there is a symbolic name present in our program, we can replace them with the original memory references. So we can see that if there is any type of a references variable that we have used, or anything there is a type of an error is there, so we can fix at this particular part. That is a resolution part. Fine. So we are completed with this class loader subsystem with two tasks we have done. One is the loading part, that will load a class file and store the required information in the method area. And the second part is your linking part, that will tell you that before linking the required activity, that it should verify, prepare it for the what type of a memory it required, and resolution is there if there is any type of a conflict is there and you need to resolve that particular part, that will come under this resolution. And last part is the initialization part, in which we in this process two activities will be performed, that all static variables are assigned with the original value and static block will be executed from top to bottom. This is the main task of the initial. Now we are done with this class loader part. Now what was happening here, that bytecode was given to this class loader. It has loaded that particular bytecode according to the required loader it want. After that, it is linking that particular bytecode. And in this linking part, it will check, it will verify that particular part. It will prepare if what type of a memory it requires, and it will resolve if there is any conflict between the references at all. And finally, in the initialize phase, we will see that if we are having any static variables, so we can assign them the original values. And if it is a static block, so that should be executed from the top to bottom. Okay, so what is static variable and block? So static variables are those that we cannot change. Okay, so it will assign all those values. So here, now this particular portion has been finished. Now we move towards the memory area part. Now in this memory area part, we have divided this in JVM. There are 5 types of memory areas. So one is we have that method area, and this is a method area. Also, it has been wrongly written as a memory area. So method area is there, heap area is there, stack area, PC register, and the native method area. Fine. So these are some of the, we can say that native method area. So these are the different memory areas that is available to us. So we will discuss again one by one. So first of all, we are having this method area. So method area is created when JVM is started. So as soon as you start the JVM, your method area will be created. So what it will do, it will store the class file information that we have already discussed in the class loader. That all those information of that class file will be stored in the method area. Plus, it will also keep the static variable. Okay, so per JVM, one memory area will be given. So therefore, multiple thread can access to this area. Okay, so it is not a thread save. Basically, we can say that the method area is not a thread save. Next type of area is a heap area that is created when JVM is started. Okay, so what it can do, that it stores the object, instance variable, and arrays. Okay, so heap area is created when JVM is started. Okay, so this is also created when your JVM will start. So it will store your objects, instance variables, and arrays. What method area stores? It stores only the class information. And what heap area will do? It will store the object, instance variable, and the arrays. Okay, so it can be accessed by multiple threads, so that data stored in heap area is here also it is not thread safe. Fine. Third type of area is a stack area. So when we require the stack area, when we will create a new thread over here. So a separate stack area will be created. So when we do this discussion, when we have discussion on that multi-threading, that this particular thing will be more clear to you. That for every thread, whenever the thread is created, a separate stack area is also created. But meanwhile, you just understand that it also stores the current running method and the local variables. So local variables are stored in this particular stack area. And what type of a variable it stores? That is the instance variables. Clear? So this is the heap area. Stack area is there. So when the method is completed, the corresponding entry from the stack will be removed. So after, when all the method calls are completed, then only the stack will become empty, and that empty stack is then destroyed by the JVM. Okay, so this is the main purpose of this stack area. So this is just for the knowledge that you must understand that how this JVM will work. So we are using all these particular things. Okay. So these are the different types of area, but you must remember all these things, because it will help you when we do the corresponding program. Then we will able to understand at that which particular memory area, what type of a data is being stored. Next is your memory areas. So in this particular memory areas, we will hold the address of the next executing instruction. Fine. So what we are holding the address of the next executing instruction that is being stored in the PC register. Okay. So we are storing that particular value to the PC register over there. So as you know that PC register is what? That is a program counter register. Okay. So what it will do? It will hold the address of the next executing instruction. So for every thread, a separate PC register is created. So we can say that it is a thread safe. Okay, so we can say that it is a thread safe. Last one is a native method stack. Now, what is this native method stack? That it will include all the thread. It can call invoked by the thread will be stored in the corresponding native methods. Now, what is this native method? These are those methods that are not directly belong to this Java library, but we have to include them. Okay, but that may belong to some another language or some other platform, but we are including them using the different native method stacks. So for every thread, separate native method stack will be created. So it is also a thread safe. Fine. So next is so this was all about, if you remember this particular diagram. So we have a class loader. Again, I am repeating. So bytecode will act as an input to this class loader. So what this class loader will do, that it will define you the type of a loader that you will be using. So and it will include each and every information of that particular class, and it will store each and everything in this particular method area. Okay, and then we have in this particular class loader, we have the linking part. So that linking part will link to the required particular memory that it require. Okay, so it will go for all those particular thing. And the third one was the initialization part. So initialization part, it will initialize all those static variables or a static method that is using. So if you are using a static method, it has to run, start running from the top to bottom. After this class loader, we have to decide that at which particular memory area we are using. So total we are having 5 memory areas, fine. But according to the type of a variable, we can decide which type of a memory area we will be using here. Like for the first area is the method area. So that will store, that is created when JVM will start, and it will store all those class information. Clear? For the heap area, it is also created when JVM is started. It stores all the instance variable and the arrays. So it can be accessed by multiple threads, so that data stored in heap area is not thread safe. So both these areas are not thread safe. Method area also and the heap area also. Third one is the stack area. So stack area is created when a new thread is created. But meanwhile, it also stores the current running method and the local variables. So that is the main purpose of this stack area. So whenever we will create a new thread, so a separate stack area will also be created. Then we have the PC register. So PC register is what that will hold the address of the next executing instruction. So for every thread, a separate PC register is created. So it is also a thread safe. So we can say that it is also a thread safe. Okay, so it also holds the address of the next executing instruction. Next is the native method stack. So what native method stack will do, that if it will see that if any native method is being used, so its particular library should be called in that particular environment. So that is a native method stacks area. Now the last part is the execution part. So we have completed with this particular class loader. We have completed all these memory areas. Now the last part is the execution part. So what we will do, we will move towards this execution engine part. And if you see this execution engine part, now this is the main heart of our JVM, or we can say that this is the main central component of the JVM. Okay, now this particular execution engine will consist of so many components, and the main components are, that is the interpreter, okay, the JIT compiler, that is just-in-time compiler, and the last one is the garbage collector, security manager, and so on. Okay, so interpreter is what? That will check your line by line code and will check if there is any type of error. And just-in-time compiler, what it will do, it will just intermediate the code generator. It is the intermediate part of the code generator. It will optimize your code for the best solution. And finally, it will give you the target code generator. So whatever the requirement will be of that particular program, that will be filled here. That is target code generator. and finally we can get the machine code or the native code. Okay, so we can also use different we can use also profilers or a hotspot. So what basically this basically this execution engine will do, that it will define you that how main execution will be done. Fine. So what is the meaning of profiler here? So it will just tell you that what type of a program it is, and what is it will analyze the target program by collecting whatever the information it requires. Okay, so you can use different profilers over there or hotspot over there that can help you out to analyze on the information that is required while executing. Clear? So this is the main component of this execution engine. Now, execution engine is responsible to execute Java class file. Now, this is the main, that side is known as a central component because it is a main part that is required for the execution of. Okay, so execution engine is responsible to execute Java class file. So it will contain mainly two components. One is the interpreter and the second one is the just-in-time compiler. Okay, so interpreter is what? That is a module that will decodes and executes every statement or a line. So many times we have heard this term interpreter, that will decode or that will analyze your particular instruction. Okay, so it will execute line by line in your program. Okay, so here what Java interpreter will do, it will decode and execute the bytecode for the Java virtual machine. So it is taking as a bytecode as a input. So interpreter will take bytecode as an input and it will convert to the machine code or the native code. And finally, it will execute that particular. Fine. So this is what interpreter will do here. Next is that we have this execution engine here. So in that execution engine, we are having that JIT compiler. So JIT is what? That is just in time compiler, which means that code gets compiled when it is needed, not before the runtime. So main purpose of this just in time compiler is to improve the performance. So this is also one of the feature. If you remember in the features of Java, we have discussed that JIT compiler. This is according to JIT, that the performance of Java programs are much more better than the previous languages program. Okay, so what it will do, it will just JVM maintains a count as how many time a function is executed. Okay, so if that particular count exceed a predefined limit, okay, then the JIT code, what it will do, it will compile the code into the machine language, which can directly be executed, which can be directly executed by the processor. Okay, so what it will do, that it will again see that next time if the same function is calculated, so that code will be compiled, executed again, unlike the normal function, and in which the code is interpreted again line by line. So it will just check out its particular area, that if it's the same code has been compiled, so it will not ask for again and again, it can run the predefined code over there. Okay. Fine. So this makes the execution much more faster because it will run that particular code only when it is needed, but not before the time. So JIT compilation is applicable only for repeated required method, not for every method. So we don't require JIT for each and every method, but where we can find out that if some particular method or a function is being executed again and again, at that time we can record this just in time compilation. Okay, so this was according to the GIT compiler. So we have done this execution engine. So in this execution engine, two components are very important. One is the interpreter and the second one is the GIT compiler. So interpreter is like this, it will work, it will take that bytecode as a input and convert it to the machine code or a native code, and finally it will execute that one. And this is a just-in-time compiler. That means that code gets compiled when it is needed, not before that particular time. Fine. So again, there is a JTIV native interface, Java native interface. So that interface allow Java to interact with the code written in another languages. So native is what? That anything that doesn't belong to that particular environment. But Java provides us with a wonderful feature, that is an interface, Java native interface, that allows Java to interact with the code that has been written in another languages. So it acts as a mediator for a Java method calls and the corresponding native libraries. So JNI is responsible to provide information about native libraries to the JVM. Okay, so it will tell us that what are the different library you require in order, if you are interested in running some particular type of a native code that is not available in Java. So your Java native method library provides or holds native library function. So Java command line utility is an example of one such application that launches the Java code in the virtual machine. Okay, so when we perform this command line function, then you will be able to understand all these things. Fine. So this was all about the Java virtual machine. So I think that is quite interesting for you. Like if you are interested in that, how basically a JVM works. With this particular diagram, just keep this particular diagram in your mind. That will help you out in knowing that what basically how this Java program runs. Okay, and this is the main we can say that architecture of this Java part that will help us to understand that how everything works under this JVM part. Okay, so this is the main architecture of this particular this JVM structure. So we can also you just remember, like the very first component is the JRE. Okay, so JRE is what? That is a Java runtime environment. Okay, so JRE is what? Java runtime environment. That is a set of software tools. Okay, which is used to develop which are used for developing a Java application. Okay, so it is used to provide the runtime environment. So there are three types of a we can say that abbreviations we are using. One is JRE, second one is JDK, that is a Java development kit. Okay, so that is a software development kit which is used to develop the Java application and the applet. And the third one is the so JDK is there, JVM is there, and the JRE is there. So we have already done JVM portion here. Like it will just verify it is a stack machine. It will just check that particular code and give the desired output over here. Clear? So again, I just switch to the Blackboard where you can understand that how we can distinguish between these three terms. Okay, so the first thing is that the JVM part. So what is the JVM part? That is a virtual machine. So how we can represent this JVM part that we have already discussed, that it is a virtual machine. So we are writing like this. It's not visible. Virtual machine. And we have understood that what basic purpose of this JVM is. Okay, so what it performs, and it just verify that particular code virtual machine. It loads the code, verifies code, and then executes the code. So this particular thing we have discussed in so very much detail, that what basic purpose of this JVM is, right? Next is the JRE part. So what is this JRE? That is a Java runtime environment. Okay, so what is the purpose of this Java runtime environment? That will provide you the different set of software tools. Okay, so it will provide you the different set of software tools which are used for developing the Java application. Fine. So this is how we can define a word JRE. Next is the JDK. So how we can define this term JDK? That is a Java Development Kit. So what is this Java Development Kit? That is a software development environment which is also used to develop the Java application. So everything is available under this JDK. Fine. What we can say that everything is available in this particular JDK. So Java Development Kit, that is while installing this particular Java, we need to install this JDK. Fine. We need to install this particular JDK over here. Now this particular JDK will consist of this JRE and the JVM. Okay. So under this JDK, we are having this JRE, that is a Java Runtime Environment. Fine. This JRE will contain the JVM portion. This JRE will contain your JVM portion, that is a Java virtual machine. Plus, it also provides you with a different set of libraries. Okay, so it will provide you with a different set of libraries. Fine. Also, this JRE will consist of different development tools. Like as I am running my program in the command prompt, so in that case, I will be using such type of tools. Java C, that is for compilation, and simple Java for the execution of that. Fine. So this is how, don't get confused that what is JDK, JRE, and what is JDK. So JDK is the Java development kit. This is a complete set of tools. If you need to do work on Java, you need to install this JDK on your systems. Okay, so that is the JDK part in which you need to install this particular JDK. When you will install this particular JDK, automatically your JRE and JVM will be installed. So it will consist of your Java runtime environment that will further consist of all set of libraries, classes, interfaces. It will provide you with all set of classes, plus your JVM also, and the different development tools that will be automatically downloaded. So this was all about, as this was a very basic lecture in which we have just discussed that what basic environment Java has, what are the main components of its Java language, and if we want to execute some particular program in Java, okay, so what basic we require? So we require a particular JDK, that is a Java development kit that we require, and in order to use that particular kit, automatically each and everything will be displayed. Fine. I think